हेलो फ्रेंड्स, आज हम बात करेंगे उन सारे न्यूमेरिकल्स का जो एनसीईआरटी के चैप्टर फर्स्ट में अवेलेबल है एंड द चैप्टर इज इलेक्ट्रिक चार्ज एंड फील्ड्स। वन बाय वन सारे क्वेश्चन को सॉल्व करेंगे। दिस द एनसीईआरटी बुक व्हाट आई हैव and I'm going to solve all the exercise question one by one. So in this series the first one is 1.1. So let's read out the question first and then I'll proceed it. So first of all I would like to write the given quantities. So first the question is, what is the force between two small charged spheres having charges of 2 into 10 to the power minus 7 and 3 into 10 to the power minus 7 coulomb placed 30 centimeter apart in air. So first of all we should write the given quantity. Q1 is equal to 2 into 10 to the power minus 7 coulomb and Q2 is equal to 3 into 10 to the power minus 7 coulomb, if I am not wrong. Okay, yes. And the distance between the charged particle is 30 centimeter. Each quantity I have to use in SI units only. Check it. Is this SI unit? No, we have to convert this unit into SI system of units. So automatically it will be 0.3 meter. So first of all I would like to draw the diagram, actual diagram. So Q1 is equal to this and these two charged particles are separated by a small distance, that is 0.3 meter. So actual question is this, that how much force exerted between them. We have already studied by the Coulomb's law. The force between two charged particles is, that is 1 by 4 pi epsilon naught into Q1 into Q2 and divided by square of separation between them. I think there is no problem at all. And we know the value of this constant is 1 by 4 pi epsilon naught is called proportionality constant. We also called it K. So the value of this constant is 9 into 10 to the power 9 into 10 to the power 9 Newton meter square per coulomb square. So we have to use all those data. So hence force is equal to what is the value? That is 1 by 4 pi epsilon naught into Q1 into Q2 by R square. So what is the value of this constant? The constant is 9 into 10 to the power 9. What is the value of Q1? Is already given. We have to put all those value. Mind it, all those quantity must be available in SI units. Okay, we have already converted this distance in SI, that is 0.3 square. So when we solve it, we are going to get 9 to the 18, 3 is 54 into 10 to the power 977, that is minus 5 divided upon 0.06. When we solve it, we are going to get 9 into 10 to the power minus 3 Newton. I hope you have understood the concept. Okay, so one more thing. What type of charge is this? Both have positive nature. It means when they exert force between them, the nature will be repulsive. So you have to write repulsive. So now it is time to see the second question, 1.2. So first of all I have to convert it 1.2, and first of all we will write the given data. So let's see what is the question. The electrostatic force on a small sphere of charge 0.4 microcoulomb due to another small sphere of charge minus 0.8 microcoulomb in air is 0.2 Newton. Okay, you might see the question given in the exercise. So two charged particles have already given and the force between them is already given. So let us write first. So Q1 is equal to, that is, let me see, 0.4 microcoulomb and Q2 is equal to minus 0.8 microcoulomb. And already in this question, already the force between these two charged particles is given, that is 0.2 Newton. If I am not wrong, check. Let me check. Okay, yes, I am right. And what we have to find in the first part of this question, we have to find the separation between them. So no problem at all. We have to find R is equal to what? Since we know by the help of Coulomb's law, जब कभी भी दो चार्ज होते हैं उनके बीच जो फोर्स लगता है दैट इज k इंटू Q1 इंटू Q2 बाय R स्क्वायर. दिस k इज कॉल्ड प्रोपोर्शनलिटी कांस्टेंट एंड द वैल्यू ऑफ दिस कांस्टेंट k इज 9 into 10 to the power 9 न्यूटन मीटर स्क्वायर पर कूलम स्क्वायर, अगर आपको याद हो. सो वी विल यूज दैट वेरी इक्वेशन नंबर A. So force is equal to K Q1 into Q2 by R square. We have to find this separation between them. So first of all, let me draw the diagram. Q1, Q2, and the separation is R, and this very R we have to find. So let's put the value. Force is already given, that is 0.2 K, the constant, 10 to the power 9 Q1, that is 0.4 into 10 to the power minus 6. How I have written 10 to the power minus 6? Dear, the value of the micro means 10 to the power minus 6. It means the magnitude of constant micro is 10 to the power minus 6. So that I have taken here. So we use 10 to the power minus 6 again for this Q2. You students might have problem why I am not taking this negative sign. Actually, we are using the scalar form of Coulomb's law. That's why we are not having this sign negative. Okay. So we will see the nature. Okay, you might have understood, and we have to find the value of R square. So let's solve the equation. When we solve it, what we are going to get? Okay. Let me do. If I multiply these two into 10 to the power minus 3 into 0.4 divided upon 0.2. So we are going to get this. So the value of R square we are going to get, that is 14.4 into 10 to the power minus 3. So when we solve the value of this R square, so we know the concept, mathematical relation. So under root 144 into 10 to the power minus 4. See, this decimal point has gone down and automatically it is 10 to the power minus 4. Okay, I'm not wrong. So when we solve it, 12 into 10 to the power minus 2 meter. So when we convert it into centimeter, we are going to get answer 12 centimeter. So clearly we have seen the distance of separation between these two charged particles is 12 centimeter. Hope you students have. In the same question 1.2, B number question has the query like what will be the force on this second charge owing to first charge. No problem at all. जितना चार्ज ये फर्स्ट वन Q1 Q2 की वजह से फील करेगा, the same charge Q2 is going to feel. No difference at all. So we can say in the part number 2 of the same question 1.2b, so we can say the force on charge particle Q2 owing to Q1 is same. Nothing different. There is no difference at all. That is 0.2 Newton. I hope you have got it. Okay. So now we will discuss the question number 1.3. So let's change the numbering first. So what is the question? Read it. The question is, check the ratio K E square upon G mass of electron into mass of proton is dimensionless or not. We have to check either this ratio is dimensionless quantity or not. No problem at all. Let's check it. So we know this K is called electrostatic proportionality constant, and the unit of this proportionality constant is Newton meter square per Coulomb square. We know the value. No problem at all. If I want to, because I have to find dimension now, so we are only talking about unit. We should not think about the magnitude of the physical quantity. So again, this is electron. This is electron, and we know the unit of electron is Coulomb. No problem at all. This is G. What does G means? G stands for gravitational constant, and we know the value of gravitational constant, that is 6.67 in 10 power minus 11 Newton meter square per kg square. So we should not think about magnitude. We have to write only the unit, that is Newton meter square per kg square. So now the unit of mass of electron and mass of proton, no difference. Unit of mass of electron or proton is what? Kg or kg. Let's put all the units in this equation number first. So what we are going to get? Let's see the ratio. I am going to call this ratio as R. So unit of this case Newton meter square per Coulomb square. Unit of electron, that is E square, that is Coulomb square. So again we are going to write the unit of G, that is Newton meter square per kg square. Newton meter square per kg square. So we have to write the unit of mass of electron and mass of proton. Mass of electron, that is kg and kg. So if we see clearly, this Newton is going to hell. This meter square is going to hell. This Coulomb square is going to hell. Kg square, kg. So ultimately what we are going to find? We are going to find it is unitless quantity. It is, this ratio R is unitless quantity. Unitless quantity. And we know each unitless quantity is dimensionless. So we can clearly see here that the given ratio Ke square upon G, mass of electron into mass of proton, is dimensionless quantity. Because it is unitless, so without unit we can't think about dimensionless quantity. I hope you students have understood. Let me think what is the another question in the same question. What does the ratio signify? Question कहता है ये क्या signify करता है? No prob at all. Just think. Wait. No problem at all. Let me wipe it out. क्योंकि second question इसी question में आ चुका है. इसी same 1.3 का point number B आ रहा है कि ये जो ratio है क्या signify करता है. So just think ना. We know suppose two electron and proton are separated by r distance. We have already studied in 11th standard that जब कभी भी दो मैसिव पार्टिकल, आई मीन जो भी दो पार्टिकल जिसका कुछ भी मास है, अगर सेपरेटेड हो कुछ डिस्टेंस से, उनके बीच ग्रेविटेशनल फोर्स लगता है. सो इफ आई वांट टू राइट द फोर्स, ग्रेविटेशनल फोर्स बिटवीन दिस इलेक्ट्रॉन एंड प्रोटॉन, देन वी कैन राइट Fg is equal to G m1 mass of electron and mp divided upon r square. We have already studied this equation in class 11th, and we know these are electron and proton, so automatically there will be electrostatic force between them. So when we have to write the electrostatic force between these two electrons and proton, then we can write K into electron into proton divided upon r square. We know the magnitude of electron and proton is going to be same. Definitely the sign is different, but there is no need to talk about sign because we are talking about the scalar equation of electrostatic force. So when we solve it, we are going to get K square by r square. K E square by r square. When we divide this equation first and second, that is equation second with respect to first, that we are going to get the same constant. So we can clearly say that the ratio, this constant ratio, signify that this is the ratio between electrostatic force between electron and proton with respect to gravitational force between electron and proton. I hope you have understood. Now it is time to talk about question number 4. So first I have to write 1.4. See, जब कोई बात समझ में आए, कंसेप्ट जब समझ में आता है तो चीजें काफी आसान हो जाती है. 1.4 number question, what it is talking about? The first question is explain the meaning of the statement electric charge of a body is quantized. You might remember my students, when we were talking about the property of charges, electric charges, हम लोग इन चीजों पर क्लियरली बात किए हुए थे कि कोई भी बड़ी चार्ज है तो उसका द मेन रीजन इज प्रेजेंस ऑफ इलेक्ट्रॉन और presence of electron. Yes, electron, the basic reason behind the body is being charged is the electron, and we have clearly seen कोई भी बड़ी चार्ज होता है उसके पीछे रिस्पॉन्सिबल होता है इलेक्ट्रॉन, एंड वी ऑलरेडी नो दैट इलेक्ट्रॉन can't divide into another small pieces because electron is the smallest, na? Electron, proton and neutron. So we can say whenever body is charged, the number of electron must available in integer, that is 1, 2, 3, 4, 5, 6, 7. I mean, a number of electron never present in fraction. We can't think even about it. So कोई भी बड़ी चार्ज है तो इलेक्ट्रॉन की वजह से, एंड दिस इलेक्ट्रॉन मस्ट अवेलेबल इन many numbers, and that n must be integer. That is, the value of n must be 1, 2, 3 and 4, many more. Okay, so I hope you have understood कि कोई भी बड़ी चार्ज है तो उसमें नंबर ऑफ इलेक्ट्रॉन जो अवेलेबल होगा वो इंटीजर में अवेलेबल होगा. That is the mean of quantization of charge. I hope you have got it. I'm going to talk about the second point. Okay. So now it's time to talk about question number 1.5. So the question 1.5 is basically not numerical. It is like let me read out the question. When a glass rod is see clearly the question is like explain how the observation is consistent with the law of conservation of charge during charging. कैसे conservation of law follow होता है. So I do not think so there is need to talk, but let me talk. See, जब दो ऑब्जेक्ट को लाइक सिल्क के क्लॉथ को हम लोग ग्लास रड से जब रब करते हैं, सो वन इज गोइंग ग्लास रड इज गोइंग टू बी पॉजिटिव एंड सिल्क क्लॉथ इज गोइंग टू बी नेगेटिव. व्हाई? बिकॉज द रड इज are just losing the electron and cloth are just gaining the electron. It means one object is transferring the electron to the another object. So by this way we can clearly see that electron, when because by this rubbing process the body is going to body has been charged, but at the same time we didn't create electron, we didn't destroy electron, yet we got charge. So ultimately we have seen that the net charge is 0. This by this we can say conservation of charge is followed over here. So now it's time to talk about question number 1.6. So basically we will discuss about the numericals. So first of all, write the given quantity. 4 charges and placed located on corner of basically with side. What is the force on? Place, okay, clearly the question number 1.6 is given like this कि चार चार्ज पार्टिकल है एक स्क्वायर जिसकी की साइड 10 सेंटीमीटर की वो सारे के कॉर्नर पे रखी हुई, एंड हम लोगों को निकालना है कि एक सेंटर पे चार्ज रखा हुआ है उस पे नेट चार्ज कितना होने वाला है. सो फर्स्ट आई हैव टू राइट कि जो भी डेटा दिया हुआ है उसको लिखते हैं, देन वी विल डिस्कस. ओके, सो मैं हिंट्स के तौर पे फिलहाल कह सकता हूं कि प्रिंसिपल ऑफ सुपरपोजिशन यूज होगा. सो वी हैव गिवन द साइड ऑफ स्क्वायर. फर्स्ट लेट मी ड्रॉ द स्क्वायर. दिस इज द स्क्वायर and Q1, Q2, Q3 and Q4 has given here, that is the magnitude is 2 microcoulomb and Q2 is minus 5 microcoulomb, and again QC is 2 microcoulomb and Q4 is, that is minus 5 microcoulomb. These 4 charge particles are placed at the vertices of a square, and this square has side that is 10 centimeter. See बच्चा लोग, जैसे ही दिखे ये सेंटीमीटर में मेरे को कन्वर्ट करने का रे बाबा काय में मेरे को कन्वर्ट करने का ऐसा ही में, ठीक है। सो साइड ऑफ द स्क्वायर विल बी 0.1 मीटर, माइंड इट। Now the fifth charge comes into the picture and that is placed at the center of a square, that is plus 1 microcoulomb. Now we have to find what will be the net force experienced by this 1 microcoulomb charge. So हम लोग प्रिंसिपल ऑफ सुपरपोजिशन से जानते हैं, क्या जानते हैं? So इधर देखिए, प्रिंसिपल ऑफ सुपरपोजिशन। जब मेरे पास दो या दो से ज्यादा चार्ज पार्टिकल है, व्हेन वी हैव मोर देन टू चार्ज पार्टिकल लाइक सी Q1, Q2, Q3, Q4 एंड मेनी मोर। अभी तो फिलहाल के लिए 4 ले रहे हैं, है ना। सो अगर हमको फाइंड करना है कि Q1 पे कितने फोर्स एक्सपीरियंस होंगे, सो प्रिंसिपल ऑफ सुपरपोजिशन से दैट force, net force on charge number 1 will be the vector sum of this force F21, F31 and F41. What I wanted to tell you, कि अपने को कुछ नहीं करने का रे बाबा, सीधा सीधा मेरे को देखना कि कितना चार्ज पार्टिकल अवेलेबल है, सबके द्वारा लगाए गए फोर्स का, इंडिविजुअल फोर्स का सम कर देते हैं। दैट इज कॉल्ड प्रिंसिपल ऑफ सुपरपोजिशन। सो वी आर नॉट गोइंग टू डू एनीथिंग individually. We will see how much force is exerted by this charge particle which are placed at the vertices. So first this Q1 is going to apply the force. See, this is plus charge, this is plus charge. So automatically repulsion. So at this particle the direction of force will be this. So this can be written as, so net force can be written as F1c, center पे जो लगेगा F1c will be what? Whatever plus again this minus and this plus. It means this plus 1 microcoulomb fail the attraction. So the direction of force will be this. Okay, no mind. So we'll write the name is like 1 as so 1. Why should I mention it 1? We should center है ना, so center C. Okay, already mentioned था. Okay, that's great. 1C and the second one is F2C. Now the time of third charge. See, when this charge particle exert force on this center charge particle, clearly we see plus and plus. So automatically the force between them is repulsive force. So this charge particle feel the direction of force is here, and that will be F3C plus now Q4 plus and minus. It means this charge particle feel attractive force toward this Q4. So no problem at all. So if we see okay, we have to write this 4C. Now individually we will find this and we will do the calculation. This is called superposition theorem. This is called superposition theorem. When we calculate this, so what we are going to get, this value F1C, F2C, the value this, and this is going to be, according to this, magnitude is same but direction is opposite. This magnitude is same but direction is opposite. So automatically this is going to be cancelled out like this. So net force acting over the charge particle plus 1 microcoulomb which is placed at the center of square will be 0, 0, 0. आज के इस सेशन में हम डिस्कस किए 6 क्वेश्चंस को। आने वाले सेशंस में हम और भी क्वेश्चन को डील करेंगे। अब चाहते हैं कि सेशन थोड़ा छोटा रहे, कोई बात नहीं। हम लोगों के पास टोटल 34 क्वेश्चंस है। वी विल डिस्कस ऑल दोस 34 क्वेश्चंस in part. So today we have discussed 6. Okay, till then, bye bye.